In this video, we will talk about one of the topics in the Erasmus Plus project recovering, concretely the application of 3D printed construction technologies on-site for building purposes. The construction industry has been traditionally facing a series of challenges that, despite some achieved advances, remain nowadays. Among these are the high economic costs of construction activities, the high quantity of waste generated by this sector, the accident rates at work sites, the amount of time required to complete a building, the environmental impact of these activities and the buildings themselves during their life cycle, and finally, the difficulties found for applying mass customization without assuming significant costs. 3D printed construction, a currently emerging technology, arises as a possible solution to these problems. This technology is the result from applying additive manufacturing techniques to the construction sector. It implies using construction materials and printing with robotic and industrial equipment in a larger scale than usual, and consequently it entails new research challenges to make this technology ready to be used on-site. In the next few slides, we will introduce the different topics that researchers worldwide are currently studying. These are some of the advantages that are usually attributed to 3D printed construction. On the right-hand side, we can see charts of the times each one of them has been mentioned in research studies, and the times they have been actually analyzed. From these charts, it can be inferred that there is an increase of research studies in this area, with some of the advantages being more frequently mentioned, but only some of them being analyzed, mostly those of a quantitative nature. Regarding the technologies used for 3D printed construction, there are three main approaches that stand out: gantry-based systems, which work in a Cartesian volume, industrial manipulators, whether for off-site or on-site printing with a limited workspace, and mobile manipulators as a solution to that limited workspace, which needs to be increased for on-site printing purposes. There are numerous aspects that must be considered for programming and optimization of 3D printing tasks, from the design to the execution phase. The printing process involves software for modeling and simulation of printing tasks, scripts to communicate with the robotic system, features of the printing material, control of the pumping and robotic system, and even the shape and design of the printing nozzle. The determination of the printing system's workspace is another field that is being explored. While it is somehow obvious in a gantry-based system, it deserves being analyzed when using robotic manipulators that work within a revolution volume. The design of the material mixture for printing purposes is not trivial. It requires to be extrudable, but also to set and harden in a short time, in order to allow supporting the next layers that will be printed over in subsequent steps of the process. To that end, different features of the mixture must be controlled in different phases from its preparation, pumping, extrusion, and setting. A wide variety of building systems have been tested or are being explored, both based on mass or reinforced concrete. The latter has become a mainstream research field due to its importance for building higher constructions and given the complexity of including steel reinforcements during the printing process. Finally, as can be observed, a variety of elements with different shapes, such as furniture, sculpture, components, and walls, have been printed mostly at controlled environments. Printing on-site entails more difficulties to be overcome, such as being able to cover the entire construction with the printing system's workspace, working with climate conditions, configuring the entire printing system, or absorbing irregularities of the terrain, among others. However, there are already some examples of printed buildings worldwide.